Hi there. Question 37 of the Chapter 10 Polar Review asks us to find the area inside of the figure 8 of r equals 1 plus the cosine of 2 theta and outside of the circle r equals 1. One of the first things I would do is try and get a visual of what this looks like. I would do this by graphing it on my calculator. It ends up looking something, this really weird shape right here. And the area that it's asking us to find is outside of the circle here, but inside of the figure 8, as you can see here. So we're looking at the two areas on the left and the right side with the arrows pointing to it, like the fat crescent and the backwards fat crescent. Once there are multiple strategies on how you can tackle this problem, but I think the easiest way would be to find the area of one of these regions and then multiply the area by 2, because these areas are the same, because they're just like the same but flipped. So to do that, we need to know our equation of our integral for the area between two polar curves, and that is 1/2 big R squared. This should be a big R squared minus little r squared. The outside radius squared minus the inside radius squared. And I have a 2 here because for this problem we're multiplying one of the areas by 2 to find the total area. Plugging in our radiuses for each r, we get 1/2, 2 times the integral of 1/2, 1 plus cosine of 2 theta squared minus 1 squared d theta. Uh, the last thing we have to do is we need to find the limits of integration. And to do that, we need to find where they intersect. So we need to start at some point and then do the sweeping motion up to the other point. Um, Before we solve it, a good tip to do is to try and get a mental guess as to where it is. And I'm guessing this right here looks about to be a 45-degree angle or a pi over 4. Same with this. This would probably be like a negative pi over 4, but that's just my guess. It could be like pi over 3, but it should be definitely between 0 and pi over 2 for our theta, for our top one here. So to find the actual bounds, we need to set the radiuses equal to each other. I think I said that, but some simple algebra, and we get cosine of 2 theta equals 0. That thing should disappear soon. There it goes. And solving this, we get theta equals pi over 4 plus k pi. And also 3 pi over 4 plus k pi, which pretty much means whenever it's some odd integer multiplied by pi over 4, that's a solution to the intersection. Shoot. Sorry about that. Where was I? Yes. So I'm going to use negative pi over 4 to pi over 4 because I think that they're the easiest to visualize here. You could use some other ones, but try to keep it simple. Um, some will work, some won't work, but I think negative pi over 4 to pi over 4 here will work. Uh, and so plugging them in, we get the integral from negative pi over 4 to pi over 4 of 1 plus cosine 2 theta squared minus 1 squared d theta. And that gives us with our answer of pi divided by 4 plus 2. So that is the area inside of this figure 8 and outside of the circle. If you have any questions after watching this video or my other videos, please feel free to ask Mr. Chaplewski about anything. He's a great teacher. I did well with him. I hope you learned something from these videos as well. Thanks for watching this, and I am done.